Hi, my name's Terry Fogg and I live in Australia, and I've been in the computing industry for quite a long time now. More recently I've discovered Microsoft's Micro framework and I've had some fun creating a replacement keypad controller for my telescope. Mead Corporation, a company out of California, has been making a range of telescopes for a number of years. I'm fortunate to have one of their 16-inch models mounted in a dome at my house. My current telescope was made in about 1998 and includes the standard Mead keypad that is designed for all of the LX200 telescope range at the time. Here is a picture of the keypad. The keypad supplied with the telescope, as you can see, consists of a selection of keys and a 2-line by 16 character LED display. There are many functions on the keypad to control the telescope, including initial settings of time, location and type of telescope mount. The keypad also gives access to the telescope's star catalogue, displaying brief information and allowing for the users to find and slew the telescope to the selected stars in the sky. Although the keypad is functional, there are many limitations to the controller with its usability. There is a complex hierarchy of menus to access the functions and no visual representation of stars nearby. With the introduction of the .micronet framework and its use of C# and support for complex drawing, I could see a way to create a much easier to use and more informative keypad to become a replacement for the telescope. Using the Tahoe and the XB wireless components, I've been able to create a prototype keypad replacement with the following: XB wireless connection to the telescope for freedom to move around, no longer restricted by cabling, which has on occasions caused problems. I've used the hardware buttons to give me immediate access to common functions. The touchscreen allows selection of star chart areas or to provide soft buttons to improve the usability of the interface. The Ethernet connection provides setting the time accurately from a time service on the internet. And in the future, with some more experimentation, will allow access to web services offering online astronomical databases of enormous size quickly and efficiently. It will also provide smart remote connection to the telescope. The Micro framework has a lot of class. In fact, this program was created with C# and consists at the moment of 90 classes, 187 methods, 10,000 stars, 6,800 planetary coefficients, and help with a lot of examples from the internet. Within my 90 classes that I've created so far, a lot of them are astronomical classes relying on double precision floating point, which comes standard with the Micro framework. Extending the mathematics library to include additional trigonometry, cos, sine, tan will help with availability of the double precision mathematics library provided by Microsoft and a very valuable guide to trigonometry approximations by Jack Gansel. Star catalogue data was downloaded from freely available catalogues on the internet. I used Microsoft Excel to convert the data into files which could be used by my .NET programs. Astronomical algorithms and coefficients were sourced from a great book by Jean Mousse. User interface classes are one of the many significant features of the micro framework that sets this development environment apart from any other. Today we expect better user interfaces for devices. No longer is the two-line LED display acceptable. The rich set of classes has allowed me to experiment and create a better interface for my idea than I could have done with any other product that I know of in this market space. The richness of the C# language and the useful base classes supplied by Micro Framework made this project possible. I've also been surprised at the speed of execution. My application displays initially 600 stars and their scaling and calculations along with 600 constellation lines and planetary calculations very quickly. This allows me to scroll a full sky star chart and still be responsive. Features. Power of Visual Studio has allowed me to create a desktop telescope emulation project within the solution. This project is a full .NET Framework project that shares a selection of files from the Micro Framework project via included file links. The emulation program, written in C#, communicates over the USB, or Virtual Serial Port COM17, to an XB wireless development board. By running the Micro Framework project on the Tahoe board, I was able to follow the two-way serial conversation that was necessary to allow me to control the telescope. I'm now able to prove out each command is properly transferred and each response handled by emulating the telescope responses. This has been very convenient, and now I have the basis for telescope control systems that I can further develop and move to the Micro Framework at a later date. I needed to get a lot of data loaded into Micro Framework project. I found that the easiest way was to use a .NET Framework application to massage the data and create a file I could use as a resource file in the Micro Framework project. I sourced the astronomical data from the internet. I used Microsoft Excel to convert the right ascension and declination coordinates of stellar objects to my own coordinate system based on integer arc seconds. It's not apparently obvious, but the power of Visual Studio has allowed me to use the unit testing features to easily create testing procedures to exercise my algorithms within my Micro Framework project. I first created a full .NET Framework 3.5 class library and was able to add the Micro Framework references successfully to the project. Next, I added all of the routines I wanted to test to this project as links from my Micro Framework project. I found it important to include the auto-generated resource designer file to allow the project to successfully compile. I then created a standard testing project and found that the unit test wizard the easiest way to automatically create the test code skeleton for me. The unit test wizard gave me a list of classes that were in my project, which I have chosen to test the algorithms to calc Julian date and sidereal time in this example. Once the unit test has created a skeleton test, all you have to do is get some reference data. In this case, I've used the US Navy site to generate some known data which I can use to test my routines against. As you can see, I've edited the skeleton, run the test, and they have passed successfully. Developing with the .NET Micro Framework has been made easy with the emulator. Also, the fact that you can take your C# skills from desktop experience and apply them to this environment. The fact that you can set breakpoints, print debug message, single step, skip statements, move back and forths, and rerun code within the device all makes this system very productive. In the marketplace, the current microcontrollers do not have the rich support for presentation graphics. Typically, you need to write your own. The availability of the rich set of drawing primitives sets this system apart from any other. This platform allows a single person to produce a product with sophisticated graphics and user interaction through buttons and touch with little effort. The system is great for a single-purpose device. Quite often you need a device only to perform the functions you want. For For this application, I only wanted to perform the one function, control the telescope with great features. Devices also need to be instant on and low power. You can design a system with the micro framework with these features.